Hi everyone, today I'm excited to share my ECE 570 project. This is the highlights of my project on implementing self-attention generative adversarial networks, or with so-called SAGNs. Let's dive into why this project matters. We already know the GAN. The traditional GAN has some limitation on capturing remote dependencies. The motivation here is to replicate and evaluate the findings of the original SAGN paper. The problem I'm addressing is how introducing self-attention mechanisms into GANs can enhance image generation quality and capture long-range dependencies. Moving on to the implementation preparation, let's break down the key steps. The first step is dependencies. I'm using Python 3.6 and TensorFlow 1.5 for compatibility with the original SAGN code. For the codebase, leveraging the TensorFlow implementation from the paper provides a solid foundation for my work. For the datasets, I download the ImageNet dataset from the official website and pre-process the image into the TF record files using the instruction provided in the improved GNA repository. And then I place the TF record files into the .data directory. Then we can train the data and evaluate the data using the SAGN program. Now let's delve a bit deeper into the implementation details. For the codebase, I largely use the original SAGN code, but I also have some code modifications. Adjustments were made to hyperparameters, batch size, data processing, and logging mechanisms to optimize performance. You can refer to the image in this slide. This is some modifications to the discriminator of the SAGN program. For this function, I added some variables like block layers, use non-local, and use optimized block to provide some flexibility for hyperparameter tuning. Let's move on to the results and what they mean. For the positive results, generated images show a marked improvement in visual quality. Validating my modifications in hyperparameters and data preprocessing, you can check the image on the right side. This is the dog images I generated using the SAGN with hyperparameter tuning. And for the negative results, challenges persist in generating diverse outputs, especially in scenarios with complex features. But overall, it does meet my expectations. Lastly, this is my outcomes of doing this project. My project contributes valuable insights into adapting and refining the SAGN model, particularly in improving image quality. There are some challenges in achieving complete diversity underscore the noise nature of the GAN performance. However, in the future, the work may delve into more sophisticated techniques for enhanced image diversity, so we don't need to worry about this. Overall, my project aligns with the broader goal of advancing generative models, emphasizing the need for continuous exploration and refinement in artificial intelligence. Thank you for your attention. Please feel free to ask any questions.